Maybe he'll join later. Hey everyone, welcome at our regular core protocol sync this time. We'll share updates on the core protocol from last week and going into the future. And today, Ivan will be the first to present.
Sure, yeah. So let me just share the screen. Um, yeah, hold on a bit. Yeah. Uh, so here it is. Last week we finalized the pull request which I opened and reported like back last week about parallelizing plot opening for the farmer. The issue was that for the HD purposes, plot opening takes some amount of time and it can be parallelized on each individual plot, so we can open them in parallel. So nothing too fancy here. Yeah, we just like parallelized it in terms of like iterators and everything. Yeah, we just spawn like each individual task for for opening each individual plot, commitments, yeah, and farming instance. So yeah, nothing fancy, nothing too fancy here. There was a minor issue reported by Serge related to the web description in our README, so we liked that. He didn't find it in the help command also, yeah, but I pointed him to that. So yeah, it also got fixed. Apart from that, we discussed with Nazar like issue related to the adding the max plot size flag. So that basically restricts even further the size of each individual plot. Um, so we had an idea that it might be helpful for like testing purposes of a farmer in future. So I just added that. So the thing is, we take the max plot size from the metadata of the farmer from the node, and right now we also take it from the metadata, but on top of that, we override it. We override it with the max plus size which user passes if it is like if it is even smaller than the max plus size set by the consensus and by the node. Um, so that is the thing. Apart from that, we also discussed with Nazar the issue related to the optimizing solution finding. So basically, beforehand, the algorithm was as follows. Here, we had the solutions vector, and we collected every solution from our commitments database um, for the challenge, which is sent by the node. So we collected those into the vector and just took the like single solution out of those. Right now, I just implemented the solution iterator vector. Um, we just passed to it the iterator from the RocksDB, the raw iterator, and target and range. And top of that, we can do some fancy logic. So for example, here we just take like 10 solutions out of those and collect them into a vector. And after that, we just sort them and take the best out of those. Um, so I just rewritten like all this logic in terms of like this iterator. Um, yeah. So nothing new here, just changing the logic of that. So yeah, we just right now we just take first 10 solutions basically and take the closest one to the target. So we just take first 10 and after that we take the best out of those. Top of that, yesterday we finalized another issue related to the adding cache for removing the further species. So basically, basically, I was doing the benchmarking and just testing of the farmer like whole last week, and we discovered the issue that basically we have n full plots and full plots and one partial one, and at some point when we fill up the partial plot, we getting throttled by that partial float because for this partial float we were always going to the slow path. We just remove some piece which is already present there, and add the new one. So that is very slow. Yeah, here's a flame graph of that. Yeah, I showed it back yesterday. So the thing is that like the wider the line is, the more it takes time, and basically like removing the furthest moving the furthest reference to the piece basically takes like 80% of the time of the farmer. Yeah, and basically we just need um, to optimize this update max distance function. So here's VPR which does that. It just adds caching for removing those kind of pieces. And right now the flame graph looks like this. It's hard to spot those exact functions, but yeah, here's
GI clone is the easiest to spot. It's much wider now in percentage.
yeah. So basically, the whole graph got scaled down. So basically, we can even see that yeah, GI clone basically takes 35% of the time, and here GI clone takes like 6 or 7% of the time. So basically, we optimized it like five times or something. Yeah, something around that.
Do you think it's worth like implementing like the Tokyo console so you can better like optimize on the sync?
It's not, I think.
Yeah. The issue is that like for now, Cargo Flame Graph works like fine because we're just using synchronous thrust. So basically, yeah, I can show it to you. Basically,
Oh, don't bother, don't bother.
no, it's okay. Like all of the plot, it just works synchronously. So yeah, um, but that is the thing. Basically, VSPR just like adds some battery set for caching where we keep like top 100 like max distance entries for the plot, basically for the pieces. So yeah, and we just if we need to remove the piece, we just fetch one from the cache at first. Yeah, if we don't have any at cache, we just go to the RocksDB and like batch fill the cache. So basically, filling the cache also takes less time for each individual like entry. So that is the thing. Uh, yeah, but it's kind of still slow for the evicting pieces. So still this path is kind of slow, but it got like way faster before before this patch. It was like 30 seconds. Yeah, and right now it takes like 5 seconds on MyRDD for like 60 gig plot. So this kind of scale it got down. So yeah, but for plotting like sequential pieces when we're filling the unfilled plot yet, so it yeah it takes like 1 second to plot like 3 or even 4 like segments. So it's still way very slow, um, but it's way better than before, I guess. um yeah, so that's all what I did like back last week. um yeah, I guess I guess no, actually I was doing things related to the DSN. Basically we discussed with Nazar like further steps in order to like sync from sync plot of the farmer from DSN. Yeah, and I basically like did um yeah, it's simple code for like spawning each individual network identity for each plot. Yeah, but it won't work right now because libp2p lacks um, yeah lacks support of our cryptography, I guess, our keys. So yeah, I guess I'm waiting for that. Maybe we should open PR for libp2p for that.
I created issue for now.
Mhm.
We'll see what they reply.
Okay. Yeah, I guess this kind of thing is postponed for now. Yeah, right now I'm working on the like new fancy facilities for benching the farmer. We discussed yesterday, Jeremiah and Nazar, things related to that. So we basically can pass we would need to pass like some special flag in order to test like the throughput of our like HDD or SSD. Yeah, and we basically can add some fancy logic on top of that. Like for example, which stage of the pipeline of the farmer takes most of the time. So I'm working on that right now, hoping to fix that this week. Yeah, that's it from my side.
I can give a little bit of color as to why to some of the things. So the max plot size we've actually decided to add after we discovered that when you reach the full size of particular plot, it gets slower. So instead of waiting for plotting 100 gigabytes to actually observe that, we can add enforcement of, let's say, 5 gigabytes, and then we can test it much sooner. So that's just helpful for testing purposes. It's not for like production use cases necessarily. And on the optimizations for the solution search, the challenge is in our current RelayNet, where we have fixed solution range, and then the history gets bigger, bigger, bigger. We potentially will scan most of the commitments database into the vector, and then we'll pick the first one, which doesn't make any sense. So with this update, we just scan the first 10 and then we return the closest one. The other case is where you have two solutions potentially, and then of those two solutions, one is the higher quality, one is the lower quality. So it makes sense to take the higher quality one in case there is a fork and you need to account for the weight of those blocks, which will be derived from the proximity of the solution to the target. So that's a little bit more about why those updates were necessary. Any other questions, comments? Okay, Lucia, it's your turn.
Okay, sure. Let me share my screen. Okay, can you see my screen?
Yep.
Yep.
Yeah, great. So last week there are a few changes regarding the executors, but all of them I believe are pretty straightforward. The first one is to like escape the signed execution receipt processing while the primary node is major seeking. Basically, assuming like we will not like support the traditional executor thinking as like that is like kind of waste of like resources because we already depend on the primary node, so we can just like use the network status of these primary nodes to know the network, like the executor is major seeking. So we are not like gospel the signed execution receipts to the other executors, and we are not sent these signed like execution receipts to the farmers if the current if the local executor node is major seeking or is like in the initial thinking. Okay. The next one is like similar to the like signature and the signer of the execution receipt, like verification on the executors. We will also need to check the signature and the signer of the receipt on the farmer side. So yeah, should be also straightforward. Yeah, so we'll check this signature and the signer while this like Subspace execution receipts on unsigned extension was submitted to the primary node. Okay. The last one is we would like also to allow only the initial trusted on the executive authority to produce bundles, just like we only allow this initial executive authority to publish the execution receipt. So of them, I believe it's not hard to understand, I believe. The core idea is similar to the previous processing on the execution receipt. We need to know who is the expected executor that can produce the bundle, and the related signing key exists in the local key store. Then it's fine to produce this bundle with signatures and signer and this information. The other things is about this execution receipts checking in the on the primary node. I believe we'll continue the discussion on tomorrow's meeting. So I think I'll skip it for now. Yeah.
Yeah.
I have a question to Nazar and Lucheng probably. How do we test such changes? For example, checking the signing of the receipt. I don't see any testing code in the PR.
Yeah, I currently actually just run the local development network locally.
So just manual testing for now.
Yeah.
Okay.
But we can add the test for sure.
Okay, thank you.
Yeah.
Okay. In addition to that call that we have tomorrow, what are the plans for this week, or is it completely blocked?
So I just need the tomorrow's call to confirm the executor logic for the last piece for the initial executor deployment. After that, I believe I'll have everything prepared for the initial executor deployment, and then we can think about how to launch the executor chain properly against the current network,
Okay.
And once this executor chain was launched, we can discuss the next milestone. I believe is one direction is the delegation or the proof of stake of the executors. The another direction is the security step. Yeah.
The other one is what?
The security step.
Right.
I believe the currently the existing knowing improvements, optimizations will be just differ to the future. I believe we already got a bunch of introduced optimizations.
Yeah.
But
yeah, I'd like to do clean up on the CLI stuff on the Explorer chain. There are still a few data structures which we need to move.
Okay, yeah, that way, yeah, we can do that after launching the executive chain. Yeah.
Okay. Any other questions? All right. Ved, do you have something to share?
No, unfortunately, not a lot on the protocol side for me last week. I don't think there'll be much this week as well on the protocol. Mostly focused on the runtime side, getting the feeds and parachains and their verification, and I'll update in the integration sync.
Okay, makes sense. Guess let me share my stuff then. Should be this one. Okay. There were a few things, mostly cleanups. There was this small fix for the runtime start. Basically, if you are syncing from the Genesis and we are trying to query the max plot size from the runtime, in here, the old runtime doesn't have that method, so it was failing. This is just a small patch until we just reset the network next time. It's in two places. Then there was this small thing that is kind of annoying. I wanted to do it for a long time. It primarily consists of two parts. First of all, on the farmer side, we had this quite old environment variable, which was optionally supported for specifying the path where the data will be stored. And the other thing was that our folder that we were using was called Subspace under operating system specific user data folder. And that was changed to Subspace Farmer in here. And there is a compatibility small thing. When you are wiping storage, it will also wipe the old path such that you don't have that left over and occupying your disk space. So this is a simple one, and I also had to update farming instructions to include that path in Docker case because we want to use a special volume in that case. And the other commit was for the node. The default behavior from Substrate is that it was using the name of the executable as the name of the directory where the data is stored, which means every time we have a new snapshot, the new folder is created and the old one is never deleted. So what I did here, I just made it canonical. I had to override the executable name to just subspace node all the time ever. And then that's what's used. And in the wipe command, or like purge chain in this case, I've just added a bunch of names for different snapshots for different operating systems that we used in the past. And when you are trying to purge the chain, it will also delete these old ones. So that again, you will only have this one canonical and will not have this leftovers on your disk. That required a few changes and also had to rename a little bit the names of the chain directories for the executor. Otherwise, they were colliding with the same name in the consensus. The reason for that is that this executable name basically overrides what was used before in the Cumulus. It's also subspace node. So you basically have one folder where there are subfolders for executor and consensus, like all under the same tree. This was accidentally merged here. We'll consider it later. There was one comment, interesting one from Lu Cheng. He basically proposed to have the structure instead of subspace dash node and subspace dash farmer to use subspace slash. And that would make sense. It would even look nicer if you had like subspace slash desktop. So like everything is under one folder. It's a little bit challenging the way Substrate uses. It just uses the executable name for the folder, and slash is not really a name of the file. So like it just doesn't look very nice. We'll probably fix it later, but just didn't want to bother so deep in the internals of Substrate. It's kind of awkward the way they do it. I'll probably introduce another method in addition to this. This is awkward. In here, they have this method executable name. We probably need to create like executable directory or something like that we can override later to make it a little bit nicer.
Don't those slashes cause any problems on Windows because they have backflash?
It's not actually a problem. Like in 95 or 8% of cases, Windows doesn't care about forward to backward slash. So it actually works in almost all cases. So you can just not bother with that. It's the same thing kind of like on Linux or other Unix operating systems. Technically, the path is just a byte sequence, and it can contain a whole bunch of different interesting characters. But for all practical purposes, only UTF-8 is considered to be valid. So many applications will actually crash if you are using non-UTF-8 characters. And there is a whole crate on crates.io which is wrapping the native data structures from standard library and just not allows non-UTF-8 characters. So you can like make it easier, make your life easier for everything. You can like print them to the console without problems and stuff like that.
Thank you.
So yeah. Then this is what was accidentally merged here. I noticed that we are creating these snapshots in some cases just to test things, whether they work, and that's really not very convenient. So we've added another way to build those things with the manual workflow dispatch. And then the artifacts will be uploaded to the workflow itself. The way it looks, I will probably not be able to find. Let me try quickly. We have the branch here. Okay, I can just show it in my branch, I guess. So when we have this workflow, and at the very bottom of the page, we have artifacts. Yeah, in this case, it's not what I wanted. Maybe here? No. Maybe it's already deleted. I guess. Let me find another one. Yeah, I guess we can just look at the latest release in the mono repository. It should be the same kind of behavior. Yeah. Okay. And in here. So at the bottom of the summary, we have build artifacts, and we can actually download executables that we are building. It doesn't attach container images. I was thinking about exporting layers into file, but it seems to be a little bit overkill. But at least we can go to the actions, and you can go to the snapshot, runtime snapshot or regular snapshot, and you can just run this workflow on whatever branch you want. And it will build stuff, and we'll attach them to the workflow like this. So you don't have to like create a proper tag release and like bother everyone with pre-release and make everyone confused. You can just do this however often we need on demand, just for convenience. Then there were a few things regarding preparation to the release. I did some documentation updates. The most important one that most users will care about is this. So we removed some of the parameters which are hard-coded in the chain spec itself, so you don't need to specify them explicitly, but we also enabled state and block pruning. We are only storing last 1024 blocks instead of the whole history, which makes the amount of space that node is using basically constant. And most of the space will be allocated for the farmer, and on the farmer side, we need to specify the size explicitly. Those are the primary changes. There are some other small tweaks. And then what else? Then I did small tweaks to the acknowledgement. Basically, the way it worked before, we did this upgrade previous week, where before this, where we were basically made the node wait for farmer to acknowledge that the segment that was produced was actually plotted fully. And then we like continue block import and stuff, but that also means that the node is basically blocked on the in the middle of the block import pipeline and cannot proceed. And on the real chain where we have many small blocks, it could have already imported a few more blocks while the farmer is busy. So we are just taking this risk, and we are acknowledging that we've received the segment on the farmer right away. And while we are plotting it, the node can run further and sync other blocks. And by the time we are done here, hopefully there is another segment already waiting for us, and we can basically optimize this process a little bit, make it a little bit faster than it was otherwise. And the testing was done by Justin, and he confirmed that it is indeed faster. But potentially, if the farmer acknowledges and then crashes in the middle here, which should never really happen, it can potentially lose one segment and not plot it. But that shouldn't be critical, especially on the big network.
I can have a comment on that. I actually had as you know, yeah, I've tested current farmer under the Subspace.js, using the Subspace.js, and just posted the lots of bytes, probably 2 megabytes for each query. Yeah, for the node, and basically I experienced the thing after the moving to to acknowledging the segments. So basically, I experienced the thing that farmer actually crashed, even with the because node was expecting was having the timeout or something. So can't remember logs right now. But I actually experienced crashes because of that.
Okay, I can imagine one case when that might happen. So on the RPC side, we are just sending data. And when we need to do retry, we just send in data again. So maybe you can keep track of those farmers which have not replied yet and just don't send it to them specifically. But at the same time, I don't think we have a good way. Maybe we do, track who, distinguish different subscriptions. I guess we could try. Yeah, it would be nice if you can keep those logs and just post an issue so we can fix it. But I think I know what you're talking about.
Okay, yeah. If I would test some more, I would post some logs, yeah. But the thing is, this issue, I guess I never seen it for those kind of setup which you're talking about right now, moving the acknowledge part at the beginning.
Yeah, I think there was another one which was related to timeout, which we increased on the latest snapshot. There was a timeout of 5 seconds for node to reply, and if node was really busy, it may not be able to reply quickly enough, and then farmer would just crash with timeout. So it just depends on which side you've seen the error. If it was on the farmer, it's probably that timeout. But it should be increased to 60 seconds, and it should be plenty for node to reply at least something in the meantime.
Yeah.
Okay, then there were some other fixes. There was a typo in health check. Docker down instruction didn't delete volumes, which was causing some interesting side effects. There were some errors, and gigabytes and terabytes instead of just GNT were supported in the parameter because Justin hit it a few times. One of the biggest change from the README or farming instructions is that this is now explicitly a living document. So if you didn't arrive at this page through the release, you really should. You should go to releases. You need to find the release and go to the instructions from that release. And we'll update these to reflect the latest state for the particular snapshot, such that if you are doing breaking changes in the main branch, you can still go to the correct instructions for that particular release. And I updated the previous release as well. It points to the older instructions, which are up to date for that one. The idea is that we'll move this to the website at some point. Then there was a small thing I was looking at for a long time. We've had this trait thingy, which was used in a few places, but it wasn't actually super necessary. And when I deleted it, it was even less code in total, 10 lines less code. So just wasn't any reason to use that. And we also had this session key for Subspace, which we are not using on the consensus side, so it wasn't necessary. So I deleted that from the test runtime and the regular runtime as well. So that was just a minor cleanup. Then there was a typo, and there was this uncle inherent provider in our Subspace service, which we're not using because we never had uncles. This is just the way it was built with the node template, I believe, at the time when we forked it. So just clean that up. Yeah, and spent a bunch of time testing this release with Justin. So nothing major groundbreaking here. Any questions about this? In addition to that, there was a little bit of work on this issue in Substrate about extracting the syncing protocol from the networking implementation. There was this description from one of the developers at Parity to have a specific steps on what to do. The first step was to move the data structures and protocol buffers definitions into a separate crate, then move messages related to light client messaging or like protocol on the peer-to-peer level into separate crate, and then flip dependencies over such that those will depend on the networking instead of networking depending on them. So I basically did those first two steps. There was some preliminary refactoring that was merged, and then there was a pull request about the sync that was merged, and this third pull request is I will turn this branch into pull request about light client messaging. And after that, we'll probably discuss how we can actually flip the dependencies over and create abstractions in Substrate. This will be helpful for us in order to implement sync through DSN on the node in more generic way, more proper way. Right now, it's just hard-coded internally. We cannot replace it, but this should allow us to do so. So yeah, there was a little bit of work on that one. I guess that's all that I can share at this moment. Any other questions, thoughts, concerns about this or anything else?
So just one comment. So I believe after you think refactoring in Substrate, I believe you know the executor probably will not have the regular sync system, right?
Probably.
So
We're all not broadcasting blocks, like it's just a sidecar for the consensus chain, basically. Well, we have transactions. I'm not sure how we'll use transaction broadcasting, but that can also be implemented in some other way.
So just an idea, like maybe it's nice to like keep it in mind. We might like totally exclude this sync structure from the traditional nodes.
Yeah, the idea is that the sync implementation will be, well, ideally the sync implementation would be just a trait, and a C network sync will be just one implementation of that trait, and the networking will also be a trait. So we can like replace networking part of the sync and just let it route through DSN for like blocks and regular way for everything else. So we don't like replace everything at once. That would be ideal, but we'll see how far and how quickly we can go into that direction. But at least I'm trying to facilitate it as much as possible on the upstream side, so we are not as blocked on that. Even though it still takes time for the Parity folks to review it, of course. Yeah. All right, I think that's surprisingly quick today. Sam, Shamil, do you have anything else you'd like to share?
I've been going through the deployment stuff with Surge. I think what we're trying to get to, at least from a deployment point of view, is that as opposed to having most of our Terraform manifest in different directory, all our infrastructure should be controlled from one manifest, so that when we want to apply state changes, we do Terraform plan to see what has to be changed and update and delete stuff that way, because it becomes a lot more easier to manage. And Serge also took me through a lot of the backend stuff, like the relay and the archive. Okay, Nazar, you seem like you don't like that.
I have some thoughts, but please continue. I will share later.
Yeah, I just saw the Twitch like this. Yeah, and also I'll be updating. So there's a lot of deltas with documentation. So hopefully we can catch up with Leo so that we're not just deleting anything. But in the meantime, I'll be updating the infrastructure documentation and working on the first draft of the deployment and released workflows.
Yeah, on having one one like directory or one main manifest in Terraform, that makes sense. Probably in our case, while we don't have a lot of stuff, but eventually what you'll find is you'll have a Terraform plan or Terraform apply running for 60 minutes. That's not fun at all. So if you have a lot of resources, you will actually split that into like logical parts just to handle that problem.
No. I'm not talking about one manifest. No, I'm talking about there'll be logical parts, but right now we would need several state files to deal with each of them because each of them is its own directory.
Right.
So yeah.
So eventually that will be like the intended behavior, because separate states means that you don't have to scan the whole infrastructure every single time you want to like rename something. But in our case, there is not much infrastructure, so it makes sense to have one state file and just keep everything in one place.
Okay. Because okay.
I've been working with infrastructure where there are like 700 bare metal servers and a whole bunch of stuff in the cloud, and it just takes a really long time if you want to change something, like really, really long time. Just for efficiency purposes and for like if something crashes, it's much easier to block one part of the infrastructure, not the whole thing. You know, like if you interrupt the Terraform apply in the middle and you need to fix the state.
Okay. That makes sense then. We should go as we want to continue. So another thing I've done is I've created a cloud-based backend so that anyone else can pick up the state file from the backend and use it as opposed to sharing it over Google Drives.
Okay, is that in the documentation or?
That is in the documentation I'm updating.
Okay, great. Okay. I guess unless you have anything else, this is all for today. Thanks, guys, on YouTube for watching, and we'll see you next week at the same time.